Okay, so this is a question posted in our group. It says a farmer uses a machine to dig up potatoes, and the probability that a potato will be damaged by the machine is 0.1. So this indicates that a potato being digged up has only two outcomes: either it's been damaged or not damaged. So I've already done the working. I just thought I'll explain it a bit further. So that means this one has to follow a binomial distribution, and in part A they tell you that find the probability that a randomly selected 12 potatoes will include 3 damaged potatoes. So let me go back here. Normally when you do a question in statistics, you need to always define your variable clearly. So that's what I've done here. I say my x is a variable where it counts the number of potatoes that are damaged. So x has to have a binomial distribution with 12 comma 0.1. So 12 indicates the number of trials, simple n, and 0.1 is the success probability. Being a damaged potato is indicated as a success here. So in A part, they say 3 damaged potatoes. That should be according to the binomial formula. You might have learned it. 12C3 into 0.1 cube into 0.9 to the power of 9, which gives me 0.852 as my answer. Yep. And when you go back to part B, it says a random sample of n potatoes is selected. Now 12 potatoes has been replaced with n number of potatoes, but the distribution shall remain as a binomial still. They say let x be the random variable representing the number of damaged potatoes. So you can see this clearly. I have defined it once again as x being a binomial distribution, following a binomial distribution with n number of outcomes and a success probability of 0.1 still. So they tell you write down the mean and standard deviation for capital X. Right. So the mean is always considered to be the expected value, which you can see is NP. This expected value of a binomial distribution is NP. N is n and p is 0.1. Therefore EX is 0.1 n. The variance is NP into 1 minus p. That is why I multiplied by NP 1 minus p, which gives me 0.09 n. And you also know that the standard deviation of x is the square root of the variance of x. Therefore this is equal to 0.3 root n. So they say in the question use the normal approximation. So when you approximate for a normal, the expected value of the binomial distribution becomes the mean mu, and the variance becomes sigma square. Since my sigma is root 3 root n, my sigma square shall be the square of root 3 0.3 root n. Right. Now what do they ask in the question? They say use the normal approximation to show that probability of x being greater than or equal to 3 to exceed 0.95, the sample size n should satisfy this inequality. That means when you take a value for n, it should satisfy the probability of x being greater than or equal to 3 to exceed 0.95, and also it should give us this inequality. So let's see how we could arrive at this inequality. So what I did was I have already defined the distribution for x, the normal approximation of course, which is 0.1 n comma 0.3 root n whole thing square. So when I say x is greater than or equal to 3 to exceed 0.95, over here below we can convert this probability as 1 minus px less than or equal to 2, and when we simplify that we come across this inequality, which gives us that x less than or equal to 2 is less than 0.05. okay. Now before we use the approximation, we need to do the continuity correction, which is known as, now x used to be following a binomial distribution, which means x is a discrete random variable, but when you approximate as a normal distribution, you use normal distribution only for continuous random variables. That means in discrete random variables you can have damaged potatoes either 2 or 3. In between 2 and 3 there's a gap. But you can see when you come to the normal distribution, between 2 and 3 also you can't have a gap, because the normal distribution is associated with the area. Therefore, when we say x less than or equal to 2, we are sacrificing the area between, or else the width between 2 and 3. Therefore, we need to consider half of the sacrificed width, which is 0.5 between 2 and 3. That's why you can see that x is less than or equal to 2.5. You call it the continuity correction. You may inbox me if you are not clear about this continuity correction. I can still explain you with further notes and stuff. Okay, and now how do you convert this into z? You have to subtract the expected value or the mean, which is this, and then you divide by the standard deviation, which is this. So that gives you z less than 2.5 minus 0.1 n over root 3 over 0.3 root n, and this should be less than 0.05. And you know, in the normal curve, when does something becomes less than 0.05, they are talking about this area. So if you look at the normal table, you know, probability of x exceeding 0.1.6449 is 0.05, which is this part. So equal probability should occur in this side. So if this is 1.6449, this shall be minus 1.6449. So that's where we get this equation from. Since if you consider this to be an inequality like this, the right hand side is the same. Therefore, this value of 2.5 minus 0.1 n over 0.3 root n should be same as or less than this value. Yeah, this is exactly equal to 0.05. Therefore, if it is less than that, it should satisfy this inequality. That is why I have written equal sign here. So now if you rearrange the terms in this inequality, you can see clearly you will end up getting the inequality mentioned in the question. What I did was I took the denominator to the right hand side. So I got 4.9347. Then I rounded up to 3 decimal places, and that's the inequality they have given. So this can be considered as a quadratic inequality of root n. So n can be considered as y square, root n can be considered as y. So that gives a quadratic equation, and the two roots will be 8.04 and minus 3.108. Since it's an inequality, it should be this region that satisfies our requirement. And you can see root n is a positive number. It cannot be less than a negative number, so that is rejected. And root n to exceed 8.04, that means n should exceed the square of 8.04, which is 64.689. Therefore, we can say that n is equal to 65. Hope you understood.